welcome back again with the same topic, logarithmic derivatives. So day before yesterday we have solved certain questions on exercise 5.5. So few more questions on logarithmic derivative from exercise 5.5. So let us solve few more questions from the same exercise. Question is, you have to find dy upon dx of x plus 1 upon x raised to power x plus x raised to power 1 plus 1 upon x. So we have to find dy upon dx of this question. So for this, let us suppose this given function is equals to y. That means y equal to x plus x 1 upon x raised to power x. This is equal to y. So we can put this as u and this as v, or y equal to u plus v. If I take derivatives of both the sides, so I will have dy upon dx. This will equal to du upon dx plus dv upon dx. So let this be marked as equation first. So for finding the dy upon dx, first I will find the value of du upon dx, then the value of dv upon dx. Then I will substitute these two values here, and the value of dy upon dx will be come out. So the first part, that is, here I have put u equal to x plus 1 upon x raised to power x, and the second part I have put v equal to x raised to power 1 plus 1 upon x. So from these two equalities, I will find value of du upon dx from here and dv upon dx from here. So before this equation, I multiply both sides by log, or apply log to both sides. So when I apply log to both sides, so log u will equal to log of x plus 1 upon x, its raised to power x. So I have formula with me. The formula is log m raised to power n. This is n log m. The same formula was used in previous questions. So I can write log u. This exponent will come into the base in this way. So now I differentiate both the sides with respect to x. So its derivative will be 1 upon u into du upon dx. This is the derivative of left hand side and derivative of right hand side, there are two functions. One is x, one is log of x plus 1 upon x. So here I will use the product formula of differentiation. So this will be d upon dx of, the formula is uv dash, and this is equal to uv dash plus vu dash. The same formula it was used in solving the few days ago. So this formula will be applied here. So this will be first function, it is x into derivative of second. So its derivative will be 1 upon x plus 1 upon x into derivative of x plus 1 upon x. So first into derivative of second plus second function into derivative of first, that is x, its derivative is 1. So I can write 1 upon u du upon dx will equal to x here. If I take LCM here, so I will have x square plus 1 upon x here, and derivative of this x, its derivative is 1, and derivative of 1 upon x, it is 1 upon x square minus. So here I can write minus plus into minus minus 1 upon x square plus log of x plus 1 upon x, 1 multiplied by this term will give the same term. So I can write du upon dx equals to u time, I multiply u. So here I will have, this is x upon x square plus 1, and x will multiply. So I will have x square here into this term. When simplified, it will give the x square minus 1 upon x square plus log of x plus 1 upon x. So I can put, now x square and x square will cancel each other. So I will left with the final term du upon dx will equal to u time, value of u, it is x plus 1 upon x raised to power x into the term inside x square minus 1 x square plus 1 plus log of x plus 1 upon x. So this is the final value of du upon dx. In the same way, this value du upon dx is to be found out. So again here, for finding the value of dv upon dx, the same steps I will have to follow. Apply log to both sides. So here log v equal to log of x raised to power 1 plus 1 upon x. Again, using the same formula, log v, this exponent will be written in the base into log of x. So if I differentiate this with respect to x both sides, so its derivative will be 1 upon v into dv upon dx. This will be the derivative on left hand side, and derivative on right hand side. Again we have two terms, one is u and one is v. So again the same formula. First function into derivative of second. So derivative of second is 1 upon x plus second function into derivative of first, that is d upon dx of 1 plus 1 upon x. So this will be equal to, here if I take LCM, so I will have x plus 1 upon x and 1 upon x here plus log x into derivative of this term inside the bracket. So 1 is constant, its derivative will be 0, and 1 upon x, its derivative will be 1 upon x square. So I can write this as x plus 1 upon x square plus into minus will give me minus log of x square here. And this is the value of dv upon dx. If I multiply this by v, so finally the value of dv upon x will be value of v. It is x raised to the power 1 upon x into x plus 1 upon x square. I can take LCM here. So if I take LCM, so I will have x plus 1 minus sign log of x and whole upon x square. So this is the value of dv upon dx. The value of dv upon dx is known to me. Value of du upon dx is known to me. So I substitute here the values. So first, that if you want to note. So I substitute here value of du upon dx, and value of du upon dx is written here. This value, so x, this will equal to x plus 1 upon x raised to power x into x square minus 1 x square plus 1 plus log of x plus 1 upon x. So this is the value of du upon dx plus the second value dv upon dx. The value of dv upon dx is here. So I can write x raised to power 1 plus 1 upon x into this value 1 plus x minus log of x upon x square. So this is the final value of dy upon dx. So in this way, the logarithmic differentiation of the given function is calculated. So you will get definitely 6 marks question in the exam. So these are long type questions. They are frequently asked in the exam. So this was question number 6 of exercise 5.5. This was 6th question. So next question from the same exercise. Let me take another question from the same exercise. We have to find dy upon dx, and the function is x raised to power y plus y raised to power x equal to 1. So its derivative is to be found out. So this question again is to be solved in the same manner as I solved the previous one. So if this is given to me, if I say y equal to x power y power x, so its derivative I can take this as capital Y. So dy upon dx will be, let me put this y equal to u plus v. This term is to be taken as u and this term as v. So if I differentiate dy upon dx, this will equal to du upon dx, dv upon dx. Let it be the equation first. I can put this y fx also. So here again I will put u equal to this term x raised to power y and v as y raised to power x. So from here I will get du upon dx, and from here I will get dv upon dx, and lastly I will substitute both the values here. I will get the derivative. So first, to solve this, apply log to both sides. So log of u equals to log of x power y. Again, y exponent can be written as y log of x. So differentiate here. If I differentiate with respect to x, both the sides, so I will get 1 upon u du upon dx. Again, it is the product of two functions. So product of two functions, its derivative is used number of times. Same formula as used in previous case also. So this will first function into derivative of second. So log x derivative is 1 upon x plus second function into derivative of first, it will be dy upon dx. So I can write this as du upon dx equals to u times y upon x plus log of x into dy upon dx. So I can put the value of u, and value of u is x raised power y. So I can write x power y into y into x power minus 1 plus log of x into dy upon dx. So this can I write if I multiply both the term. So I will get y time into x. This bases are same and exponent are they are to be added. So it will be y minus 1 plus this multiplied by this x power y into log of x into dy upon dx. So this is the final value of du upon dx. So this value is to be substituted here. Again, in the same way, here also I have to apply log to both sides. Again, this exponent of y can be written as x log y. So again, if I differentiate the both sides with respect to x, so 1 upon v dv upon dx, it is product rule. So by product rule, the first term, then derivative of second, this is first, this is second, so it is 1 upon y into dy upon dx plus the second function, that is log y into derivative of first, that is 1. So dv upon dx will equal to v times x upon y dy upon dx plus log of y. So if I put the value of v, that is y power x into x, it can be written as x into y power minus 1 into dy upon dx plus log of y. So this can be written as x times y and y bases are same and exponent they are to be added. So y raised to power x minus 1 into dy upon dx plus this term multiplied by this will give log y. So this is the value of dv upon dx. So I have found out the two values, that is dv upon dx and du upon dx. So if I substitute here du upon dx, its value is y times x raised to power y minus 1 plus x power y into log of x dy upon dx plus the d v upon dx, it is here x time into y raised to power x minus 1 into dy upon dx, and this last term y raised to power x log of y. Now this is equal to 1, so that means this constant derivative is 0, so this whole term will be equal to 0. So I can write here I have 4 terms, so out of 4 terms dy upon dx and dy upon dx, these are the 2 terms. I can write x power y into log of x dy upon dx. This is the first term, and this is the second term, xy x minus 1 into dy upon dx, and these 2 terms, the remaining 2 terms, that is y x y minus 1, it is taken toward the other side, and this will be minus time the first term, and the second term is this, so minus y x log of y. So if I take dy upon dx as common, so inside I will have x raised to power y log of x plus here I will have x y raised to power x minus 1, and this is equal to x y minus 1 into y. I write the x as first, and here y into log y. So I have to find the value of dy upon dx. So dy upon dx will equal to this term minus sign here plus upon this term x power y log x plus x y x minus 1. So this is the final answer which we have to find out. So you can note this question also. Here, instead of this y, it is I can write in this way. So there is no need of this equating to y. So this will be 1. So its value will be 0. So that is why I have written here 0. So when I will differentiate this term, it is given x raised to y plus y raised to x equal to 1. So if I put this as u and this as v, so that means u plus v equal to 1. When I will differentiate, it will be du upon dx, dv upon dx, and its derivative is 0. So I will turn this as first term. And lastly, I will put the values here, and this is equal to 0, and that I have written this is equal to 0. one more question, that is question number 15 of this exercise. This was twelfth question which I have done. This is question number 12. Now I am going to take question number 15. So 15 number question. Of the same exercise, x, y, you have to find value of dy upon dx. Its value is to be found out, and we are given xy is equal to e raised power x minus y. So this is to be solved, its value is to be found out. So to solve this question, since it is the exercise of logarithmic differentiation, so I will have to take log both sides. So when I apply log, so it is the product of log of x, log of y, and here the exponent can written in this way, and log e, it is 1. So if I put here value 1, this will be x minus y, that is log x log y equal to x minus y. So if I differentiate with respect to x, its derivative will be 1 upon x, its derivative 1 upon y, and dy upon dx is will equal to 1 minus dy upon dx. So if I transfer this term to this side, so 1 upon y dy upon dx plus dy upon dx will equal to this term to be transferred here. It will be 1 upon x. This will be x minus 1 upon x. If I take dy upon dx as common, so 1 upon y minus 1, this is equal to x minus 1 upon x. If I take LCM here, this will be 1 minus y upon y. This is x minus 1 upon x. So my value of dy upon dx will equal to x minus 1 upon x into y upon 1 minus y, that is y time x minus 1 and x time 1 minus y. So this is the value of dy upon dx. So in this way, this is to be solved, and this was question number 15 of same exercise. So after one more question from this exercise is going to be completed. So by tomorrow we will take derivative of the next type of function, that is called parametric. So this is a exercise, small exercise. They are easy questions. 2 or 3 marks question can be asked from here. So this I will start tomorrow. One more question from this exercise. So question is 14.1 says dy upon dx, you have to find cos of x raised to power y, and this is equal to cos of y raised to power x. This is the last question of this exercise. Maximum questions I have solved. Here cos x and cos y, x is for y, y is for x. So apply log both sides. So log of cos x raised to power y equals to log of cos y raised to power x. So I can write y time log cos x equals to x time log of cos y. So this is the product of two functions. Left hand side and right hand side is again the product of two functions. Here u is y, this is v, u and v. So if I differentiate, so d upon dx of y log cos x equals to d upon dx of x into log of cos y. So product rule will be applied here and product rule of derivative will be applied here. So this will equal to, first this is u, this is v. Again this is first function, this is second function. The first function into derivative of second, its derivative will be 1 upon cos x into derivative of cos x plus the second function into derivative of the first, this will be dy upon dx. So similarly here the first function into derivative of second into derivative of cos y into dy upon dx. First into derivative of second plus second into derivative of first, that is 1. So this will equal to 1 y into 1 upon cos x derivative of cos x, it is minus sin x plus log of cos x into dy upon dx equals to here x time and it is cos y. Derivative of cos y is minus sin y, so I will have minus sin y upon cos y and dy upon dx plus log of cos of y. So this will be y time minus sin x cos x, it will be minus time tangent x here plus log cos x dy upon dx equals to minus sin y upon cos y. This will be tangent of y into dy upon dx and plus here log of cos y. Now I have two terms of dy upon dx. One is here, one is here. I transfer this to this side. Log of cos x into dy upon dx, and this is transferred here, so this will be plus x time tangent y into dy upon dx. This will equal to, this term is already on right hand side, log of cos y, and this term from left is to be transferred to right side, so this will become y positive tangent of x. So if I take common dy upon dx, so inside I will have log of cos of x plus x time tangent of y, and this will equal to I can write this as y tangent x plus log of cos y. So my dy upon dx will finally equal to y tangent x log of cos y upon this term log of cos x plus x tangent y. In this way, this value of dy upon dx is calculated. So for today, these are sufficient questions. You may try these at your home. So next, I am going to take parametric differentiation. Till then, it is bye.